Hello there, seventh grade. How are you? I hope you had a good weekend. Um, so let's learn about probability and how to describe the likelihood of an event. So you've probably heard of probability already. Have you ever heard that there's a 0% chance of something? So for example, I believe there's a 0% chance of me growing 10 inches by tomorrow, right? That's impossible. Um, One thing that I'm certain about that's 100% is I am certain it is 100% that tomorrow the sun will rise in the morning. Okay, so that talks to you about percentages. Okay, um, let's say that I had two pens in this cup. One is light green, the other one is red. Okay, what's the probability of when I close my eyes and I randomly pick a green one? Okay, oh, it's a red one. When I randomly pick a red one, what's the probability? Okay, it's a 50-50 chance because I have one of each in here. Okay, so it's a 50-50 chance. So each of these, there's an equal chance of them being picked. Okay, so that's called 50-50. Okay, or a 50% chance of something being picked. All right. The closer we get to 1, when it's a fraction, okay, it's most likely to happen. The closer we get to 0, it's less likely to happen. All right. And probabilities can be written by using a percent, a decimal, or a fraction between 0 and 1. Okay? So you can see here, the percent is in the middle here. The fraction between 0 and 1 is here at the top. And the decimal between 0 and 0.0 and 1.0 is at the bottom here. Okay? All right, let's look at this example. So let's say you flip a fair coin. It is impossible for the coin to land on the edge. Okay, so that means if you have a coin, and let's say this was a giant coin and I flip it, okay, it's impossible that it'll just land on the edge like this. Okay, it's saying for this scenario. I don't think it is impossible. I think it is slightly possible for it to happen. I've seen it. But, in this case, they're telling you it's impossible. Just let's pretend that it's impossible. And this word fair, a fair coin means that it's not biased, okay? That there's an equal chance of heads and tails to be up on the ground, okay? And so the sample space is the equally possible outcomes in this scenario, which is just heads or tails. And so what's the probability that it'll land on heads? Well, because there's 2 choices and heads is one of the choice, it's 1 out of the 2 choices, right, in the sample space. Okay, so it's about 50%. Okay, and let's think about this scenario. Let's say that a coin is biased so that it is more likely to land on heads than on tails. Would the probability of getting heads be greater than or less than 1/2? Which one means it's more likely? It has to be greater than 1/2, right? That means it's more likely for it to land on heads if it is a biased coin where it'll land on heads more than tails. All right, now part B asks, what is the probability that the coin will land on both heads and tails? So it'll land on both heads and tails. So you'll be able to see both heads and tails. That's 0% chance, right? Because it's only one side or the other side and it cannot land on its edge like this. Okay, so the probability of a coin landing on both heads and tails is 0. All right, pause the video, try numbers 1 and 2 on your own, and when you're ready, let's check our answers together. Hey, how was it? All right, let's look at number 1. We're rolling a fair number die. Now, a die has how many sides total? There's 6 sides on a die, okay? And the sample space of a die, we have the numbers 1, 2, 3, 4, 5, and 6, okay? So now, How many total outcomes are there? Well, let's look at the sample space. There are 6 outcomes when you roll a number die. All the outcomes are equally likely, okay? Because it's a fair die, it's not biased. So the probability of getting a 4 is, how many 4s are there? There's 1 4, right? Out of how many choices? Equally likely choices. 1, 2, 3, 4, 5. Out of 6 equally likely choices. So the probability is 1/6, okay? Find the probability of getting a 7. Let's see. Let's look in the sample space. Is there a 7? There's no 7, right? So it is impossible to get a 7 when you roll a standard number die. So the probability of getting a 7 is 0. Let's look at number 2. When you spin the spinner here, right, what is the probability that the arrow will point to a number? Well, let's look at all the, I see colors here of orange and green, and I see letters. I don't see any numbers. So the probability of the arrow pointing to a number on this spinner is 0. Okay. All right, let's keep going. Let's learn how to find the probability of an event. So to find the probability of an event, okay, what we're going to do is let A stand for that specific event, and we're going to write it as a fraction, okay, where the numerator is the number of outcomes favorable to event A, and the denominator is the total number of equally likely outcomes. In other words, the denominator is the number of items in the sample space, and the numerator is the number of favorable items in the sample space, okay? And again, they denote n as number of favorable items in the sample space and n as the number of items in the sample space for event A. So let's look at this example. A pebble is picked at random from a bag containing 6 gray pebbles, 9 white pebbles, and 5 tan pebbles. Let B be the event of picking a white pebble. Well, let's first write the sample space. Now, we don't have to always write the sample space because sample space can be really large, but just for the sake of this example, I'm going to write out the sample space, okay? So the sample space are the equally favored outcomes that can come out, okay? So we have 6 gray pebbles, 1, 2, 3, 4, 5, 6, 9 white pebbles, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 5 tan pebbles, 1, 2, 3, 4, 5, okay? So B is the event of picking a white pebble, okay? So A, find the probability that event B will occur. So to find event B, okay, the probability of event B is we have to write what's the total number of equally likely outcomes? Okay, so we got to do 6 plus 9 plus 5, which is 20. And now we have to see B, the probability that event B will occur. So event B is a favorable number of outcomes, which is picking a white pebble. Let's see how many white pebbles there are. There's 9 white pebbles. So I'm going to write that in the numerator. So this is my probability of picking a white pebble is 9 out of 20. Now we're going to express this answer in as a percent. So what I like to do is I prefer to compare my numerator to the number 100. That way I can easily find the percent. Okay? So I'm going to take my probability, which is 9/20, and I want my denominator to be 100. So 20 times what gets me 100? It's 5. So whatever I do to the denominator, I have to do to my numerator to get an equivalent fraction. Okay? And so 9 times 5 is 45. So 45 compared to 100 is 45%. All right, now it's your turn. Please try numbers 3 and 4 on your own. Okay? All right, see you soon. Hello, how was it? Let's try number 3. So in here, Max has 4 short sleeve shirts and 5 long sleeve shirts in his closet. X is the event of Max randomly choosing a long sleeve shirt. Find probability of X, which is probability of choosing a long sleeve shirt. Express the probability as a fraction. So event X has how many favorable outcomes? So before we do that, let's find the sample space of the equally possible outcomes. Okay, so that would be the sample space. And again, I just wrote it out here, but again, you don't have to write it out. In the future, I'm just writing it out so then it's ingrained in your head what a sample space is. It's the total possible outcomes that are equally likely, okay, given the scenario. So here we have 1, 2, 3, 4 short sleeve shirts and 1, 2, 3, 4, 5 long sleeve shirts, okay? And then event X has how many favorable outcomes? What is event X? Well, event X is choosing a long sleeve shirt. So there's 1, 2, 3, 4, 5, okay? So then their event X has 5 favorable outcomes. So the probability of event X, which is choosing a long sleeve shirt, is equal to the number of outcomes favorable to event X over the total number of equally likely outcomes. So total number of equally likely outcomes is 4 plus 5, which is 9, and there are 5 long sleeve shirts, so it's 5 nines. So there are 5 long sleeve shirts out of 9 shirts. Let's look at number 4. A box contains 28 pink ribbons and 12 green ribbons. You randomly take a ribbon from the box without looking. Find the probability of picking a pink ribbon. Express the probability as a percent. So first, let's talk about the sample space, okay? Now, I'm not going to write the sample space because it's going to be quite large if I write these out individually, but I know what my sample space is. It's actually here. Okay, it's 28 pink ribbons and 12 green ribbons. So when you add them together, you get 40. And I'm going to put that in my denominator. And then what is my favorable outcome of picking a pink ribbon? Well, there are 28 pink ribbons. So I'm going to write that in my numerator over there. Okay? But my goal is to write this as a percent. For me to write it as a percent, I want to compare a number to 100. But before I do that, I can't think of a number where 40 times a number is equal to 100. That's easy for me to figure out. But I notice I can get my denominator to be a 10. So that's what I'm going to do. I'm going to divide my numerator and denominator by 4. So then I get a fraction with the denominator, an equivalent fraction with a denominator of 10, so 7 tenths. Now I can change my denominator to be an equivalent fraction of 100. Right, by multiplying the numerator and denominator by 10, and then I get 70 100ths. So 70 is being compared to 100, so that's my percent, which is 70%. All right, well, keep practicing and prepare any questions you have for me on Thursday. In the meantime, just work on your homework and look at the videos and read the textbook and look at online resources. All right, bye. Have a good day. See you later.